Very good morning, all participants. Welcome to the first session of day 3 in the 5 days training program. In the first session, I will cover this flood management practices being adopted in India, specifically focusing in northeast states, Brahmaputra, Barak, and the remaining river basins. What are the flood management practices and types, causes of floods, the background of floods, then initiative by Central Water Commission, other state departments which are carrying out to manage the flood. So I'll take you through some basic as well as the mitigation measures of the floods in this presentation. What is flood? Because you all are aware, flood, you define them, there are a lot of definition, but where generally, the dry land, dry place, the water, inundated water, which cause huge amount of loss or losses to the property, human, infrastructure, and we call it flood. I have seen last 2-3 years in the Assam, intense short duration, high magnitude rainfall spells are being occurred during the monsoon season, specifically the urban flooding being caused by all these rain spells which are witnessing the flood like situation here in especially Guwahati and other towns like Silchar and all. Apart from this, the Brahmaputra is causing flood in the nearby communities, towns, the agriculture fields, because of the breaches of embankments and many places. We have completed one project in Kopili River Basin, left bank tributary of Brahmaputra River. I have seen the downstream districts which are almost 100% flood impacted and almost on every year, nowadays 22, 23, 24 and last year also the basin has witnessed flooding at a lot of places. So there are some reasons why the flood is happening. There are several reasons. I will cover all these reasons one by one and what are the measures we can adopt to mitigate those flood issues. You can see some images of recent years. 2025 May, I was also suffered in this flooding event, the Guwahati. Entire Guwahati city was flooded. The most of the prime locations of the Guwahati city were flooded for 2-3 days continuously. There was a heavy downpour of the rainfall. The major highways like the highway which is connecting airport from this main city center, it was obstructed by the floods in between, and lot of places like the central Guwahati, the Hatigaon, these places like Basista, lot of flooding was there, and this is keep happening because of some reasons like the heavy rainfall as well as the drainage congestion in the city, the encroachment at the many places, and then debris within the local nalas in the city. So these are the main causes of flooding and the city level flooding. And the Brahmaputra river, then other tributaries, there are other regions of flooding like upstream runoff. If the higher amount of rainfall is happening upstream catchments, then it's generating high amount of runoff, and it's in downstream part of the basin, it's creating huge flooding scenarios in the downstream part. So Silchar, Guwahati, then Nagaon, Morigaon, and Golaghat. These are the few places. Dibrugarh is the town which is situated near the Brahmaputra bank. So these are the few towns in the Assam and northeast region which are witnessing flood kind of situation in almost on every year or for alternate years. So in India there are number of river basins. Central Water Commission has classified around 22 river basins of India. Major river basins are Brahmaputra, Ganga, Krishna, Godavari, and Kaveri. These are the major basins in the India. Some of them are draining the water in Bay of Bengal. Some of them are draining water in Arabian Sea and Bay of Bengal. The major two river system, Ganga, Brahmaputra river system, draining water in the Bay of Bengal. These are some events in the past few years. Now, this is all data, recent, last few years data have not been added, but you can see the states like Assam, Uttar Pradesh, Bihar, Andhra Pradesh, these are witnessing the flooding and the huge losses, and property losses, then other infrastructure losses, then there are human life for also witness, lot of property damages, then lot of displacement of all these humanities, communities which are living nearby to the river bank. So the agencies are conducting studies, what are the flooding and the flood affected areas, what are the major losses, like disaster management authorities of the states and the National Disaster Management Authority, NDMA, they are conducting the post flood evaluation, what is the damage caused, and you can see the data are saying the damages and all these are increasing year by year. We are implementing lot of mitigation measures, structural as well as non-structural measures, which I will be covering in the next slides. What are those measures? But still the problem is increasing year by year as far as the Ganges, the Brahmaputra river are concerned. Then Bihar, Uttar Pradesh, Assam, these are the states highly affected by flooding in these years. The major cause of flood is the rainfall. India Meteorological Department had classified the rainfall in the different categories. In your mobile phone, the regional Met Center, which is in Guwahati, Met Center, the regional office of IMD. So you might be receiving your notification in your mobile phone, okay, and the Met Department is forecasting heavy rainfall, moderate rainfall, or very heavy rainfall in your region, locality. So how they have classified these magnitude, heavy, very heavy, extreme heavy rainfall. So they have classified depending upon the magnitude of 24-hour accumulated rainfall. If the magnitude is crossed, the 24-hour accumulated rainfall is greater than 64.5 mm, then it's called heavy rainfall. If the magnitude is 115.6 to up to 205, then it's called very heavy rainfall. And there are extremely heavy rainfall if the daily accumulated rainfall is greater than 205 mm. So likewise they have classified the rainfall depending upon their magnitude, 24-hour accumulated rainfall, because the Met Department is having the observatory and RTDAS, and they have some forecasting mechanism like GFS, WRF, so they can predict which area is going to witness what amount of rainfall. So they are sending alarming the meteorological forecast. Similarly, once the rainfall happened and then they creating the flood, flows, volume, then the agency, the central agency, Central Water Commission, is also sending some notification based on the water level rise on these monitoring stations. The agencies monitoring for entire India, and almost on all the states they have good amount of network. Apart from this, the WRDs and irrigation department and PHED, these departments are also monitoring, not the water level, but this rainfall observatory they are having for their different purposes, for their like automatic weather station or manual observations. And CWC is also conducting a study considering the property and damages, whatever damages caused to the properties, households, then livestock, and human life lost. So they are conducting the assessment for, they have started conducting from 1951, and on alternate year they are publishing reports, CWC publishing report, considering the damages occurred. So most of the states, these states, I am saying the losses are increasing, and in spite of they are also putting some mitigation measures, but still the problem is same. I mean, this map is prepared by NRSC showing the flood affected area in India. You can see entire Ganges Brahmaputra belt is flood affected, starting from Himachal, Uttarakhand, Uttar Pradesh, then Bihar, then West Bengal, and then Brahmaputra, the Assam, Arunachal Pradesh. These are the states. Assam is the majorly affected by the Brahmaputra if you talk about the northeast state, and the West Bengal as well. So as I also showed this plot in the last presentation, the highest flood affected state is Bihar, followed by Assam, the West Bengal, Uttar Pradesh. The Bihar is about 45 to 50% flood affected area. See the total case, I mean geographical area of Bihar, then about 50% area is flood affected, and 35% area is of Assam state is flood affected. So lot of, I mean, there are some districts like as I mentioned, Morigaon, Nagaon, these are the districts which are basically near the confluence of the major river system and tributary. Like Brahmaputra, we have lot of tributaries, North Bank and South Bank tributaries. Wherever there is a confluence, the flooding problem, the major problem is there, flooding apart from the upper reaches. The reason is whenever the tributaries meets to the main Brahmaputra river, the backflow, the carrying capacity of the channel there, then there are some embankment breaches, also the incidents are happening near this. So these areas, I mean, I'll show you the map of Brahmaputra showing flood affected state and the districts in Assam and other states. So nearby the main river system, most of the area is prone to flooding, all along the north bank as well as the south bank tributaries. So these are 8 northeast states, and if you talk about the damages, so last 4 or 5 years damages from 2018 to 22, these are the statistics. Assam state is the highly flood affected in terms of the houses damages, the livestock lost and human loss, crop area affected, agriculture field. The major flood affected state in the northeast is the Assam. Specifically for Assam, because this is the most flood affected state in the northeast region, the agencies like Assam Disaster Management Authority in association with National Remote Sensing Agency, they are carrying out studies. I mean 2025 also they have published one report, and they have considered, I mean the NRSC has considered satellite imageries for last, let's say 26 years from 1998 to 2023. They have considered satellite imagery, the satellite based assessment they have done, then they have categorized the districts based on their assessment. What they have considered, which location, I mean in the districts are witnessing the recurring flooding, the places where the almost on every year or on alternate years the problems of floods are there. So they have, I mean, associated one rank for this. I mean the higher the occurrences, higher the rank. Then apart from this, what is the flood affected area of the district? It is greater than 40%. I mean they have classified the range. If this is 0 to 10%, then rank, I mean, one value they have assigned, then 11 to 20, then 2, 3, 4, 5. If the flood affected area of the district is from 91 to 100, when all 100% area affected, then they have given the rank 10. So likewise, one more parameter they have added, these districts are having flood monitoring sites of the Central Water Commission. So Central Water Commission has, I mean, all these sites are having one cross-section profile, you know? And then mostly you understood the sites are established near the bridge or where the cross section is confined. Okay, so may not be that change in the cross section over the time. So the cross section they have defined 2 or 3 benchmarks. I mean, level benchmarks. One is first one is warning level. They have defined one for each cross section. They have defined and these benchmarks. First one is the warning level. Warning level, nothing but if your water level is below the warning level, then they call normal flood situation. I mean, there is no probability of flooding. I mean, nearby area, downstream of the site and nearby area. And another benchmark is the danger level. So your water level approaching from warning to danger level or crossing the danger level, then they call orange alert or the severe flood condition. So the authorities are, I mean, planning depending upon the levels. Okay, do we need to evacuate the public or the, I mean, whatever the settlements are there, the nearby area. So they are planning according to these levels, because CWC and WRDs of the states are and providing the bulletins. If the flooding situation is there, then on hourly basis or 2 hourly basis or 6 hourly basis, depending upon the severity of the flood, they are issuing the warning. So second call orange alert, basically severe flood condition. And one benchmark is at particular site, particular location, if your water level is highest, I mean, is crossed all your previous, I mean, recordings, then we call highest flood level, HFL. So you might have seen near all the gauging sites, near bridges, the pillars, you might have seen this number, the HFL recorded in 2002, this much of level. So once your water level at that particular site, it crossed the HFL, highest flood level, then the flooding situation, the red alert they call, and the extreme or flooding situation, means you need to take action. I mean, you need to evacuate the nearby area and you have to plan the routes, roads, everything. You need to, the disaster management authority, then relief camps and all, I mean, they get activated based on these levels. So while preparing those flood severity index for a state like Assam, as I mentioning, they have considered this parameter as well. I mean, at particular district, is there are 2 sites, 1 site, 3 sites. In total duration, I mean, for 25 years period, how many times your water level crossed above the danger level? If it is more than 2 times, 5 times, 10 times, accordingly they have assigned the index for this. Combining all these 3 parameters, aggregated severity index they have provided, and they have ranked all the districts of Assam state depending upon the severity index. So in this map you can see mostly the districts are out of 35 districts in Assam, about 18 to 20 districts are in high severity flood index. And mostly those districts are, I mean, nearby, their position is nearby the Brahmaputra and the tributaries where the confluence point is there. The upper reaches are not part of this. Likewise, in the Barak system also, there are 2-3 districts which falls under this category. So this analysis, that earlier also they have published similar report, but what this analysis shows, more than 50% districts of the Assam state are falls under high severity index, high flood severity index, and moderate. There are few moderate which are in yellow color, and then rest are in, I mean, low severity. So likewise they have classified depending upon the occurrences of flooding, the water level occurrences at the particular site, and then flood affected area of the district depending upon the. And IIT Guwahati is also contributed in this study, and then Chief Minister Office, Secretary Office, they have published this report last year in May 2025. Some of you might have already aware of this document, how they have classified and categorized this. Northeast river basins. Apart from this Brahmaputra and Assam, there are some incidents, I mean, happening in like Silchar in 2022. The entire town was flooded. The reason? Heavy rainfall. flash flood was kind of situation was there, the heavy rainfall was there, and these incidents are happening. I mean, many places, many cities, many agriculture fields are upstream part. Then flash flood kind of situation are also there. The authorities are reporting these incidents, and these incidents, the high amount of rainfall, short duration, high amount of rainfall, they are witnessing floods in downstream part of the basin, our town, our locality. So these are the reason, like the intensity of rainfall. I have already discussed how the intensity of rainfall is classified by Met Department. So the India Meteorology Department is having the regional offices. Here the regional office is near the airport, the Guwahati and Med Center. So they are, I mean, the text messages they are sending during the monsoon season, you might be receiving that notification in your mobile phone, depending upon which locality you are residing. Okay, these areas will be receiving high amount of rainfall, heavy amount of rainfall in these. So Met Department is sending those notifications. So this is the one cause, heavy rainfall in the upstream catchment. Another one is the topography. Like in the last session, I showed one of in my presentations that in the Brahmaputra, in the upper catchment, the steep slope is there. And the lower, I mean, Assam and the Arunachal, the plain part, the slope is not much. I mean, the gentle slope is there. Whatever sediment that river is carrying, taking from upper catchment, now depending upon the slope of this lower part or gentle slope, it's being accumulated in this river system, which is reducing the carrying capacity of the channel, and the water is spreading in the plain part. So this is also creating the flood. And during this time, because there are embankment, the river is jacketed by embankment. So if your capacity is reduced, then flood is spreading. Then it's also depending upon the vulnerability of the embankment, type and their vulnerability, the embankment breach incidents are happening in all over the river stage of, if you talk about the Brahmaputra. Also the flood, the shape of the river system also contribute to the flood, because you can see in the figure there are the catchment area is similar in both the watersheds, but you can see the elongated watershed will generate the lower magnitude flood, and this the round shape watershed will generate higher amount of flood. Why? Because the flood, the catchment, there are number of, let's say one catchment is there and there are 10 sub catchments are there. So depending upon the location of the subcatchment, their travel time would be different depending upon their location. If we are estimating or seeing their the magnitude of flood near the outlet, then what we are considering on which catchment, which subcatchment, and what time it will create the maximum volume of the water, considering the rainfall in the subcatchment. So if the catchments are uniformly distributed and they're like the first catchment and their travel time are more or less same, 2 hours, 3 hours, then all the subcatchments will contribute at the same time. Maybe in the difference of half an hour time, they will accumulate entire water in the same time, which will add up and it will create the peak volume. The next catchment, the upper catchment, the travel time is higher because the flood will take longer time to reach the outlet. In the lower catchment, the immediately flood will reach to the outlet, considering their location in this basin. So the lower part will contribute first, and then upper catchment will contribute after some time, depending upon their travel time. So once the upper catchment contribution comes from the upper catchment, the contribution of lower catchment already recede, or what it already, the effect already is gone. So this is how the shape of the catchment plays a role while accumulating the flood and generating the peak flood at a particular location near the outlet of the catchment. As I mentioned, sedimentation is the reservoir sediment and the river deposition and the erosion and deposition. These are the phenomena of the river. Like Brahmaputra, this is the major characteristics of the Brahmaputra. There are some localities where always erosion is happening, and then some localities where deposition are happening. And there the reservoir are locations, the deposition happens. So it also reduces the capacity of the reservoir. So during the flood, because the role of reservoir is what the you are, I mean, most of the reservoirs in the northeast states are run of the river. There is not much storage capacity. The prime objective is to I mean, generate the electricity power. But there are some reservoirs, their purpose is like Subansiri, lower Subansiri, to control the flood. Considering the storage structure, the volume, the reservoir capacity, the objective is how you can reduce the flood. During the peak season, if there is a huge inflows from upstream side, then you can store in your reservoir. But because of the sediment deposition in the reservoir, you cannot hold water beyond a certain limit. So this is also causing then aggregating properties of the river, which also reducing this capacity, and bank overtopping, as I mentioned. Because of these reasons, the banks are overtopping, the embankment are breaching, which are creating flood. So in northeast, especially in the Assam, the wetlands, there are number of wetlands are there, and the wetlands which are located near the river, they are also observing some flood. I mean, they are also accommodating some volume of water during the flood. So they are holding the water for some time, and then once the water recedes, they are, I mean, losing this water. So they are also playing a role, I mean, to reduce the flood somehow, up to some extent, if their location is near the river. So these are also playing a role in controlling the flood. Another cause of flooding is obstruction in the river channel. Obstruction in the river channel, like the right hand side figure you can see, this is not from northeast state, but you can see one example, the Himachal Pradesh. Landslide reduces this channel, entire this incident has blocked the channel entirely. So what will the water will divert in some other locality, diversion will be there, and then there will be the flooding problem in the downstream part. And there are some other reasons like encroachment of the riverbed, river bank, the floodplain area encroachment, and then collapse of bridges. Few examples of Arunachal are there. Then, sir, because of some reasons, the whole region is congestion and obstruction in the channel corridor. So these are some reasons. And near the culverts, bridges, you might have seen, I mean, and the most of the places you might have seen, there are some long wood or tree wood or mixed debris, tree branches, whatever obstructions are there, they are also creating. I have seen, I mean, near in Kopli Basin, when you are crossing the the river, and you can see, because most of the places the culverts are there, the small rivers, the water is passing through the some circular or rectangular culverts. So the culverts are blocked by some regions, some debris, trees, woods. So they are also creating flooding problem in the upstream region. I have seen this incident in the Itanagar as well, in the downstream of Doimu Ghat, where some, I forgot the name of the channels, but tributaries, but they are joining, they are crossing one bridge. So I have seen similar incident where the river path has been blocked by some wooden blocks or debris. So they are creating problem because near the low-lying area and the communities are living there. So these things are creating flooding problem. This is an example of 2022, where because of various reasons the floods happened in like Kolam River, the seepage was there, huge property loss was there in downstream area. Then Chambal riverfront, I mean Rajasthan, the Kota barrage is there where Chambal river is passing through. Then Kota barrage, huge inflow was there in 2022. Then they released the the flow, and the downstream localities, downstream part was heavily flooded. There are a lot of agriculture property losses were there. And Silchar, if anyone from you belongs to this Barak region, you might have seen in 2022 what was the situation in the Silchar because of the extreme rainfall in this area. And the Kadem Dam in Telangana, the Pamba Dam in Tamil Nadu, the one gate was damaged. So it was, the authority was unable to hold the water in this barrage. So it was again created the flooding problem. So these are some examples. Now we have discussed what is the flood, what is the rainfall, water level, how the warnings are being disseminated by authorities, types of floods, causes of floods we have already discussed. But what are the measures? I mean, how we can control the flooding? There are some measures are there. Authorities has being, implemented those measures. There are two broad categories of flooding. The structural measures, like you, in your department, mostly you are measuring or controlling the flood using the structural measures. Constructing a levee, constructing embankment, some storage structures, the diversion, then detention basins, and then this river training. All these structural measures, I hope your department this way or that way, might be aware of this. Your department is taking care of these structural measures in your basin to reduce the flood. Okay, so dams and reservoir to store the water. Though there are purposes are different, but you can use the reservoir or dam to control the flood. Control the flood and to divert the water. If you have high amount of water in the particular basin and you have the water diversion scheme, or you have a storage and diversion scheme there, then you can hold the water, you can divert to the next nearby area or nearby river, considering the volume of water generated in your basin, in your stream. So this is also, dams and reservoirs also plays a good role in controlling the flood. Then embankment and levees, we already discussed. Channel improvement. Now this is not widely, not accepted, but being considered in India. Channel improvement, the dredging of the channel. As I mentioned, the sediment deposition problem is always there in northeast states, because upstream catchments are carrying, the rivers are carrying the sediment and they are depositing near the reservoir or the channel. So to improve the water conveyance capacity of that channel, you have to adopt this channel improvement. Some departments are also conducting, but this is not a feasible solution, because in the one season, once you consider this approach to reduce the flood and to strengthen or improve the water conveyance capacity of the river system, the next flood season or after 1 month, 2 months, 3 months, again you will get this deposition there. So this is not a feasible solution. Still, some authorities are considering this flood diversion channel. As I mentioned, you have a storage scheme there, and then you can divert your water depending upon what amount of water is being generated in your basin. Then detention basins are also there, like the oxbow lakes, wetlands, and tal, beels, which can be used to store the water for some time, hold the water, and once the peak is released, then you can release the water. Like these are playing a good role, specifically in Assam, for reducing the flood. The non-structural measures is the important, which authorities are nowadays focusing, which involve a lot of expertise and the computational power. So these are the few things. Central Water Commission, like they are sending this bulletin. IMD, they are sending some warnings. So these warnings, the background work, the objective of these sending these are warning to reduce the flood, to aware the people that okay, you can remove your property or your asset from there, so that there should be the minimum loss of flood. So flood forecasting and warning. Almost all the states in India are using this approach to reduce the flood loss. You cannot prevent the flood, but through the non-structural measures, you can reduce the losses. Ahead of the time, you can send the advisories, the bulletins to the concerned authorities, so that they can act upon, what will be the flooding scenario in next 24 hours, 48 hours and 72 hours. Accordingly, they can plan. The relief agencies can also act upon, depending upon what is the flood condition. So in flood forecasting, the models are there. The flood forecasting model, they are considering some forecasting input. Let's say CWC is issuing forecasting, so they have developed some models. Though there are two methods of Central Water Commission, how they are issuing the forecasting. The one is the conventional method. What is it? Gauge to gauge correlation. How many of you know what is gauge to gauge correlation of issuing the flood advisory? Have you heard this word, gauge to gauge correlation? No? Gauge to gauge correlation is nothing but you have a upstream site. Let's say example of Copley River basins. In upper reaches near the LKHP, you have one monitoring site where you are monitoring the water level. Okay, and then downstream site, Nagaon or Jaki Bhagatgaon, whatever the gauging site is there, the downstream part, 10 kilometer, 15 kilometer, 20 kilometer downstream, you have another gauging site. There are two gauging sites. Here you are monitoring the water level or discharge, and based on this data, historical data, as I mentioned, the site here upstream, if you measuring some discharge or water level at particular site which are located in upstream part, then depending upon travel time, you can estimate at what time your flood peak will reach the downstream site. After 2 hours, 3 hours, depending upon the slope, topography of the river, their longitudinal profile, and this travel time. Okay, so depending upon your topography of the river as well as the travel time being taken, the flood wave reach from upstream to downstream site, you can decide if you have measured Q amount of discharge at the particular site in upstream, then downstream site, you can send warnings or you can estimate in ahead of the time. Okay, I have measured something, I mean some discharge amount or water level here, then what would be my water level at downstream site which is located 20 kilometer downstream of the river channel, I mean that particular site. So you can estimate in advance what would be your water level at that particular site. This is the gauge to gauge correlation Central Water Commission is adopting, I mean, while releasing the bulletin, this approach. Because you have historical data, 20 years, 30 years you have data, this amount of Q and water level, this is the water level near and I mean discharge the downstream side. So you have, I mean, correlation between these two sides, considering the different magnitude of the discharge. So you know at upstream side you have measured some discharge, then you can estimate using the gauge to gauge correlation what would be my discharge at downstream site which is located 20-25 kilometer downstream that particular site, and what would be the water level there. So this is the conventional approach. The another approach, modeling system, the flood forecasting models. The flood forecasting model considers the input as the rainfall forecast, because India Meteorological Department is also releasing or publishing the data, the forecasting, I mean what will be the rainfall in next day, 24 hours and then 48 hours, 3 days advance in the forecast. They are have modeling capabilities considering the different the climatic conditions. So IMD is predicting, their WRF model is there. So IMD is predicting what would be the rainfall at that particular district locality in 3 days after. So if you put that amount, X amount of rainfall is going to happen at that particular site and 48 hours after or 72 after, then I can take that input in my model, the hydrological model, because I know the rainfall, what will be the rainfall which will happen in next 3 days. So I can take the input that rainfall in my model, hydrological model, and I can predict what will be the discharge and water level at the downstream site. This approach is much accurate because the models are considering lot of all the whatever the ground reality is there, that loss, percolations, infiltration, evapotranspiration, then channel losses, conveyance losses, then your routing losses, whatever in reality the losses are there, and time. Models are capable to capture all those information. Then model can predict better than your conventional approach. So Central Water Commission and other authorities, they are using this approach as well. We are also, as I mentioned in my first presentation, there are few states in India we are providing this. We have developed some platform. We have used the hydrological model. Hydrological model is nothing but it is the rainfall to runoff conversion. X amount of rainfall, 100 mm rainfall is there. Depending upon the hydrological characteristics of your catchments, what would be the runoff at my outlet? So I can estimate the runoff. Then I have hydraulic model. So I can take an input, this X amount of the Q amount of runoff in the input, the hydraulic model, I can predict what would be my discharge or water level at this particular site. We will explain what are the hydrological hydraulic model, what are the parameter cross section we consider, what are their functionality. We have scheduled some hands-on exercises on those modeling packages. So there are open source model, you can use it and you can at least understand what is hydrological model, what are the input parameters considers, and what is the output of hydrological model, and what are the various functionalities parameters and hydraulic model also. Like these two tools are open source tools and you can have a look over it. So non-structural measures are, there is no protection wall or some construction. These are the some technology based solutions which provides the early dissemination of flood warning or rainfall warning. We can show you what type of warnings the authorities are providing. Then okay, I'll be coming on this. I have few slides. Floodplain zoning. You belongs to which department, which state? Water Resources Department. So okay, Meghalaya. Who is from Meghalaya? The WRD Meghalaya. You are okay. So in 2022 we have executed one project there in Meghalaya, 4 river basins. Wa Umkra. Wa means river. We came to know this. Wa means river. Wa Umkra in the Shillong. Then Nonba river. Then Jowai, the Mintudu river is there. There are 3 force rivers were there. We have used the cross section survey. We have physical surveyed those rivers. We developed the hydraulic model for those rivers, and considering, because there are some regulations, guidelines, considering different amount of the magnitude of rainfall, like 5 years, 25 years, 50 years, 100 years, we have developed some scenarios. Your this is 5-year return period map, this is 10-year return period map, this is 25-year return period map. Higher the return period, higher the magnitude of flood, and higher the zoning. So I'll show you how the floodplain zoning is being carried out. So we have developed the zoning because you can do this exercise, but the implementing this floodplain zoning in the ground, it is a challenge, because someone is already there, already established their home property there. Then you ask him, okay, you remove your property from here because your house is falling in the zone A, B, C. So it is not possible to implement those regulations in the ground, but at least you should know what are those regulations. So I'll take you to you those slides. Then insurance after the flood, post flood insurance, then mitigate this the rehabilitation plans, then fundings and all flood affected communities, the training program, then all this happening. So these are the different things. So structural measures can reduce the flood because you are implementing the measures on the ground, so you can reduce. But non-structural measures can reduce the flood by sending the warnings, alarming the people, nearby communities, people ahead of the time. So you can reduce the impact of flood. The structural approach, you already aware of how to to diversion, detention basins, embankments, levees, all you can. Then training works, as I mentioned, like you can dredging the channel. Like this project I am referring, we have suggested some solutions for these rivers. Like one of the recommendation was dredging of the river system. Through the machines you can enhance this capacity of the river. You can remove the sands deposition and from the river, but it is not a feasible solution, as I mentioned, because after 2-3 months all these your work will vanish. So these are some structural measures. Your departments, you might have already done this, and you are doing this exercise in your respective river basins. The detention basins, as I mentioned, the oxbow lakes and all, you can, lakes are near the adjoining to the river basin, then you can create a connection, because some lakes are there, the connection between the lake or wetland or river is already, there is no connection, but you should create a connection so that during the high flood events, your detention basins or wetlands can consume or accommodate some amount of flood, so that the peak can be reduced to minimize the losses on the downstream part. So these are also the options to reduce the flood. Encroachment you can reduce, but this is not in your hand, and this is in nobody's hand, because encroachment, all river basins in the India, whether it is northeast, it is south part, northern part, wherever, then Delhi also. I'm living in Delhi. Yamuna, you might have heard that flooding in the Yamuna in the last few years. So there are some problems. I mean, that nearby localities, in the TV channels you are listening, how many people are affected. The people number is, counted based on where they are living, where they are settled their houses. So if your house in the floodplain area zones, then ultimately, because after few years, river, has to take their, way. So you have to think over those points where the mitigations or the protections measures are considered for these flood mitigation measures. Embankments, there are different types of, you aware of those, the geobags, geotubes, then some locations are there. Then RCC, the porcupines in the Morrigaon district in Assam. Then some examples show in the protection with boulders spurs in Dibrugarh, Assam. These are some photographs. Then construction, upgrading the embankment river works along the Beki River, reducing the flood and river bank erosion. Then bioengineering measures. So these are some other measures are also there, like nature-based solutions are also there. Nowadays, they are also the green solutions. They are coming in picture to reduce the flooding and as a mitigation measures options. Channelization of river, as I've discussed, nothing but see that this is braided river, and all these, obstruction you can remove. Then the final, after the channelization, your river looks like this. So these are some options. Then the gabion wall structures, then geobags. These are also some options to reduce the flood. Diversion of water, the river interlinking. There are some projects in the Arunachal. I have seen the Ranganidhi. The water is being diverted to another river. The purpose is to generate the power as well as to reduce the flood. So you can use, then provide water for irrigation fields. So once you have mechanism to divert the water, you can use it for multi-purpose. You can use for irrigation, you can use it for reduce the flood, you can use it for transport the water scarcity, the regions, to provide the domestic water supply. So multi-purpose uses are there if you use the water. So watershed management, like local catchment area treatment to reduce, because these measures in the master plan, as I mentioned in my first lecture, we will be identifying some basin specific issues. Some basin may have another, like the drinking water problem, the water quality problem, then ecological balance problem, and then the landslide prone basins. In this Arunachal part. So basin and locality problems are there. We will be identifying those basins. Some of the examples we already shown in last slides. But before formulating the master plan document, all these issues will be addressed, and along with the issues, the feasible solution will also be suggested or recommended, provided. So catchment area treatment is also one of them. You can stabilize using bunds, and you can stabilize the catchment to reduce the erosion. You can store water harvesting structure. You can reduce those soil erosions, and like to maintain the ecological or fisheries, you can store the water for this purpose. For aquaculture point of view, you can produce the fish production to enhance the local livelihood for the region. So you can store some water depending upon the feasible location. Then you can provide like industrial waste is the major problem of the water quality. Then you can reduce the industrial waste. So these kind of recommendation will be provided in the master plan, and then basin specific recommendation will be there. Non-structural measures, as I mentioned, floodplain management, floodplain zoning, and disaster relief. These are the post-flood, like flood fighting and awareness, flood insurance, disaster relief. These are the post-flood activities. But I mean, before the flood, you have these are the flood proofing, preparedness, response, flood forecasting, warning, floodplain zoning. So this is the slide for flood forecasting. How this flood forecasting system works. You have rainfall forecasting, as I mentioned, from the Met Department. 3 days, 4 days, even up to 7 days, even for 15 days rainfall forecast you can have. But higher the lead time, lower the accuracy. I can predict better for tomorrow, 24 hours. I cannot predict so accurate for what will happen in after 15 days. At least 24 hours, I can predict based on some weather conditions, some models. Department can predict the better rainfall forecast accuracy for at least 24 hours ahead what will going to happen. And the Met agencies are doing this, and then forecasting they are issuing. This is accurate. The earlier days there was no technology. Then if the Met Department issuing the warning, okay, you take these measures because this amount of rainfall is going to happen in this region, then there was no rainfall. But nowadays, if Met Department is predicting something, then they are predicting very heavy rainfall for some area. At least you get heavy rainfall on those regions. So the prediction is accurate nowadays. So IMD is providing the rainfall forecast, and based on rainfall forecast, we have the modeling system, which can take the input, the rainfall forecast, and then considering all those modeling parameters, we can predict, because mostly the flood is generated by the rainfall. The embankment breach, this we cannot predict because the soil properties, their vulnerability comes in picture. But at least considering the X magnitude of rainfall, you can predict what will be my runoff, considering the losses and all. So modeling system, we can issue the warning forecast. So CWC has mandate to issue the warning. As far as the hydrological forecast is concerned, the level forecasting and discharge forecast is concerned. So this is network of Central Water Commission for entire India. What you can see, the dots are there. The location of the monitoring sites are there. Different colors are there. They are showing what is the condition of forecast. Today's condition of forecast. This I captured in this morning. So what is the condition as of now? If your color is green, the location color is green, the normal flood situation is there, means water level is below warning level. And the orange, I think I can see in the middle of this map, the orange color is there. Orange color means your water level at that particular site is crossed your warning level. The red color, water level is crossed at HFL, like you can see in this map. This is the forecasting of the one site in Kopli River, Kampur, in Nagaon district. The Kopli is the south bank tributary of Brahmaputra. So you can see there are 3 lines. Yellow line is warning level. What is the level? 59.5 meter. Then orange level 60.5 meter, and 61.79 is highest observed flood level there. So in May 12 there was normal flooding situation till May 13. Now on May 13 the water level crossed warning level, the next day it crossed danger level, then next day it crossed on 15th extreme flood level was there, they crossed the HFL. So the agency like Central Water Commission, before issuing the flood bulletin, they are using this method. Your water level is above the yellow line, which is this warning level. Your yellow alert, water level crosses the danger level, the orange alert, then warning level, this water level crosses this HFL level, then red alert. Okay, so red alert is once your water level crossed above the HFL, extreme flood situation. So similar, the departments, the state agencies, disaster management authorities are also considering the same approach, how they are issuing the water level forecasting. In Northeast, these are the sites. Inflow forecast, reservoir locations, you have reservoir location, then you can predict, the CWC provide the information what would be the inflow. Inflow means what would be the contribution from upstream catchment at your particular site. So, and level forecasting means when we are providing only the level forecasting, what would be the level for next 24 hours. Then level monitoring, you are not providing any forecasting, but you are simply monitoring the levels. You, like for conventional method, as I mentioned, from the level monitoring side, you can predict forecasting for downstream site. But at that particular base station, you are only monitoring the level. You are not providing any forecasting. So, you see, Assam is the highest share, 83 the total sites, 47 level monitoring site, 37 forecasting site. It's considered all these tributaries, Brahmaputra and all. So, this is how the Nagaland is only one site is there. I forget Nagaland, I think Dhansiri, no, Dhansiri, there is no site, but there is one site in Nagaland, one site in Manipur, and there are number of sites in Meghalaya, the central water, and then states are also maintaining some sites. The floodplain zoning, as you are asking, floodplain zoning, you have in the right hand side, these are the guidelines provided by National Disaster Management Authorities. You understand return period, 5 return period flood, 25 return period flood. So depending upon your flooding scenario, these are the central one is the normal channel, blue color. Then frequent flood meaning once in a year, in 2 years, once in 3 years, or almost in every year, once in 2 years, a 2 year return period. If I am saying my at particular river channel at outlet, my flood 25-year flood is 5,000 cubic, it means the probability of happening this flood is once in a 25 year. Out of 25 years, once it can happen. This is the probability. So NDMA, guidelines are saying that your establishment should be follow this floodplain guidelines. So while you are developing the floodplain zoning, if you define the floodplain zoning, then you have to prepare 3 maps. One is 2-year return period flood map, then 25-year return period flood map, and then 100-year return period flood map. So categories are there, 1, 2, 3. 3-1 is 2 years. Second is 25 years. First class is 100 years. So in 100-year flood zone, this is the green color. You can set up your factory, your powerhouse, the university, you can set up all these. But you cannot set up the power house or any industry in class 2nd or 3 because they are falls under frequent flood and flood once in 25 years. So there are some rules are there, regulations are there. People are following it, some people are not following it, but these are the rules provided by National Disaster Management Authority. So government offices you can set up in zone 2, not in zone 3, because zone 3 are the zones where frequent flooding possibilities are there. The residential area you can set up in the zone 2 once in 25 years. We can bear once the flood in 25 years. Hospitals, the other industrial we can set up in the zone 1, not in zone 2 and zone 3. So these are some rules. And park you don't have any losses or the impact. So once the water recede, then you can use for your purpose, and park you can use for for the purpose it has been built. So these are some guidelines provided by National Disaster Management Authority, how to define the floodplain zones and what purpose you can use those zones. But mostly you can see nowadays mostly the people are living either in normal channel or in zone 3. You can find lot of houses, they're set up. So that's why they are facing the problem of recurring flooding and the issues. How many states? Yeah. Uttar Pradesh is the Uttar Pradesh, Uttarakhand, and they have already, when the Uttar Pradesh, the few stretches, they have already conducted a study from upstream to downstream. They are carrying out 3 parts. So 2 parts they already prepared. And NIH is preparing, I mean, doing this study. And some, like Uttarakhand, they have already developed. Then there are few states in line. Like Meghalaya, I am saying, we small project we have done, but we have provided report to the government of this Meghalaya, but I don't know the implementation strategy, because implementation is the major problem. As I mentioned you, I mean, this implementation is the major problem. You can prepare the maps and all, you can, but why this is the major problem? Challenge, as I mentioned, mostly the communities, people are living in the, either mostly in the main channel. I have seen some places, your river is passing just below your houses, and you have managed such a way, bridge and your house is there. River is passing through, I mean, your house, or I mean, just below to your house. So you can't do anything. Then mostly the settlements are in zone 3. So governments are having some plans, but let's see, some states are, you know, coming forward. They are preparing these zones, floodplain zonings. As I mentioned, Uttarakhand and Uttar Pradesh already they are developed for some researches. Some other states are also doing this, but I can give you the list, proper list. I can. No, they have developed, but implementation also they have done. Implementation also they have done. Like UP, I have seen them. They have removed some settlement from this area because their houses are, I mean, their properties are falling in this zone 2 or zone 3 or the river channel. So implementation also to some extent they have, but it is not so easy. The challenge is always there. Okay, so these are some challenges. You are already aware what are those challenges. I will not discuss those challenges here. So reservoir operation, like flood control, reservoir can be used, I already discussed. Then application of the space technologies, remote sensing and satellite imagery. You can, from the satellite imagery, you can see what is the flooding area in the basin. You can estimate, you can do the change deduction also. As one of my fellow briefed you that you have imagery for number of years. Then you can see what changes occurring over the years from the imageries. Like forest area is decreasing, the settlement is increasing, flood prone area increasing, or your sediment erosion part is increasing, or different kind of, I mean, your land use planning, you can see over the years what is the changes is happening in my basin. So my fellow Mr. Nitish will show you the case study of Dikrong, how the things are changing there. From the satellite imagery point of view, you can see, from the ground information, you can see how the things are changing there. I mean, as far as the land use regulation or planning is concerned. So there are one category of damages. I am not going to take much time here because you are already aware that some are direct damages, some indirect damages, tangible losses, intangible losses. You all are aware what kind of losses are there. So I will not speak much here in this slide. And this is all about the flood management, their measures, mitigation measures, the agencies, what the states are doing this. And if you have any query, doubt, we can discuss right now, and we can discuss after the session as well. Yes. 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 Very good question. So yes. Yeah, very good question. Thank you for this. So my answer for this, we will classify their, I mean, when we are recommending some schemes, then we will classify when long term, short term, and the medium term, depending upon their category of the classes. So if I am local specific issue like water quality issue or water diversion or embankment, or I'm creating some storage structures. So depending upon the type of recommendation we'll provide in the master plan, there will be the plan. I mean, this is valid up to 2 years, 3 years only. I mean, short term plan is there, then mid term plan is there, then long term plan which will last up to 15, 20 years like this. So we, and SOP also will show you the SOP we have prepared this. So based on the classification, what kind of recommendation we are providing, there will be, I mean, the plan with this short term plan or mid term plan or long term plan. So this plan is valid for this much year. I mean, you cannot, I mean, for a small scheme, you cannot plan it for 50 years, or this is for short term planning, like for 2 years, 1 year, 6 months, like this. So this will be considered. Yeah, it was no earlier master plan. There are a lot of the gaps were there. So that's why we are preparing those. I mean, revise. Yes, you're true. Yeah, but we will have this classification of, when based on recommendation, the associated classification will also be there. And apart from this, the funding mechanism, like you are saying that we were tried to get approval, then approval you received after 3, 4, 5 years. So we will also, because approving authority are same, but funding agency may change. If you are planning to set up one scheme there, then in your department, in your agency, the approval stages are same. I mean, you have to first approve from your department officials, then from Ministry of Jal Shakti or whatever agencies are there. They will be same for all the scheme. But the funding agency may differ. That will depend on which scheme you are planning to set up this project. Whether it is them centrally funded project or internationally funded project or your local state funded project. So the funding mechanism will also become along with this. So we'll try to classify the recommendations and the, I mean, whatever we are suggesting. Yes, time bind, like as I mentioned, short term 0 to 3 years, or not more than 2 years or 3 years, then up to 7 years or 8 years mid-term plan. Then there are some schemes which will last more than 15 years, 20 years. It may take some time. So that will be long-term plans. So likewise, we will classify those, I mean, schemes. Any other question? Thank you very much for your time and attention. Now we can have a tea break. Thanks a lot. Thank you.